Chapter 10 is about thermodynamics. So in this chapter we are going to see 3 lessons. There are 3 lessons. The first lesson is about the relationship between work and heat. What is the relationship between work, what's work, and what the meaning of heat. We will see the relationship between work done and the amount of heat energy transferred from one object to another object. So like for example, when we exert some force on a given object, like if you have a piston, a container in which has a piston, so when you are doing work in this container filled with a gas through the piston, so we mean that we are just increasing the internal energy of the object, or we are changing the internal energy of the object, or we might give heat to the system. So in that case we are going to see the relationship between heat and the amount of work done by the gas inside the cylinder, or the amount of work done on the gas. So we'll see 2 cases now. Heat can be like here, if you have a cylinder, a container filled with a cylinder, a gas, if you have a gas, a container in which gas is inside, so there is a piston here, so we might do work on the piston, we might do work on the gas through the piston, or the gas might do work on us. So there, or in other way, we might add heat to the system. Heat might be added, we can add heat, or heat might be released from the system. So in this lesson we are going to see the relationship between heat and the work done. That's the first lesson of this chapter. And the second lesson is about the first law of thermodynamics. So here we will state the law of thermodynamics. By the way, the first law of thermodynamics is similar with the law of conservation of energy. So the first law of thermodynamics is similar with, or it is a derivation or part of the law of conservation of energy. The law of conservation of energy. We know that the law of conservation of energy states that energy is neither created nor destroyed, but it can be transformed from one form to another form. Like kinetic energy might be transformed to potential energy, or potential energy might be transformed to kinetic energy, or chemical energy can be transformed to kinetic energy. So there will be transformation of energy, but the total mechanical energy remains constant. So the first law of thermodynamics is part of the law of conservation of energy. Like if you have a system, and if you apply some work, if you do some work on the system, so there will be change in the internal energy of the system. So the total change in the internal energy of the system is the sum of the amount of heat energy added to the system plus the total work done to the system, or the total work done on the system. Because, like for example, because according to the law of conservation of energy before, or the total energy remains constant. So whenever we are doing work, the work done on the system plus the system might observe some kind of heat energy. That's Q is the amount of heat energy. So this total energy will not go anywhere. It will be gained by the internal energy of the system. That will be the same as the change in the internal energy of the system. So this law is called the first law of thermodynamics. The third law of thermodynamics is about the efficiency of. This is a law that states about the third law of the third section is about the second law of thermodynamics. So that is about, this law states or highlights about the efficiency of a machine, or efficiency of the heat engines. That's efficiency of energy converters. It talks about the working performance of some energy converter, some device like a refrigerator, like heat engines. So this is a law this law states about the working performance of these devices. That is called the efficiency of the device. So these are the three lessons that we are going to see in this chapter. First lesson is the relationship between heat and work. The second lesson is about the first law of thermodynamics, whereas the third lesson is the second law of thermodynamics. So these are the three lessons that we are going to see in this chapter. But before that, thermodynamics is a branch of, it's a normally is a branch of physics that says about thermodynamic activities. This is a process. Thermodynamics, dynamic process is a process. There are processes that takes place, and that process is called a thermodynamic process. So a thermodynamic process is a process here where there are different processes or changes. So this is a process that happens or occurs. This occurs or happens if there is. This is a process that occurs or happens when there is a change in any of the thermodynamic parameters. Like if there is a change in any of the thermodynamic parameters, like pressure, that happens when there is a change in pressure, volume, or temperature. So the process that occurs whenever there is change in these thermodynamic parameters is called a thermodynamic process. If this is a process, or these are called thermodynamic coordinates. So a thermodynamic process is a process that occurs or that happens or that takes place when there is a change in pressure, volume, or temperature. So whenever there is change in either of these parameters or two of these parameters, the process will take place, and that process is called a thermodynamic process. And these are called thermodynamic coordinates. So a thermodynamic process is a process that occurs whenever there is change in these thermodynamic coordinates. By the pressure, volume, and temperature are called thermodynamic coordinates. Thermodynamic coordinates. So a thermodynamic process is a process that can occur or that can happen whenever there is change in either of these thermodynamic coordinates. This is like a highlight, this is the introductory part of this chapter. Now let's move on to the first section of this chapter, that's about the relationship between heat and work. So the first section of this chapter is about the relationship between heat and work. For example, what's the meaning of work? What's a system? What's an environment? So for example, here we are going to see a simple case, a simple kind of experiment. We have a Bunsen burner and a flask filled with water inside. So when this burner, this Bunsen burner heats up the container filled with water, there will be a transfer of heat energy from the Bunsen burner to the water. So this case, the water is going to boil, is going to start. Like for example, as the temperature rises, so temperature starts to rise, so there will be work, there will be a transfer of heat. So energy is now transferred as a form of heat from the Bunsen burner to the water. There will be here, and there is a balloon just at the top of this flask, at the top of this container. So when this burner light gives heat to the water, so it means that it is transferring its heat energy. So energy is transferred as a form of heat to the water. So as the temperature rises, the water is going to reach its boiling point. And we know that the boiling point of water is 100 degrees centigrade. So when the temperature reaches the boiling point of the water, that's 100 degrees centigrade, so the water starts to convert its state. there will be change of state. There will be a change of state. When you say change of state, the liquid starts to change to steam. So now, as the temperature rises, as we give heat to the water, the temperature of the water will increase continuously. Once the temperature reaches 100 degrees centigrade, there will not be any change in the temperature of the water. That means there will be a change of state. The liquid water is now going to be changed to steam. So now, as this water absorbs heat, gains energy, as a form of heat, the water molecules start to expand, or the wet liquid water will be converted to gas, to steam. So this steam is going to start to do work on the air outside the balloon. So these gas particles are going to expand. Okay, this case the balloon is now going to get to lose energy. So this case, this flask is now, the gas particles are now doing work. So there is work then. Now when this steam gas particles start to expand, they will have kinetic energy. They are going to move fastly. They will start moving. So they will start to do work on the air outside the balloon. So that's the meaning of work then. Like we have for a linear case, if you have a certain block, and if you apply some force on this object, and if you just let the force to move some distance, if this force makes the object to move, to displace some distance, we can say that this force is now doing work, and the work done by this force is defined as force multiplied by the displacement of the object, F times D. So the work done on or by the gas is now, this gas is now, the gas is doing work on the air outside the balloon. There will be a transfer of heat energy. By the way, this is called this experiment, or this is called a system. So this is called a system. We have here, in this case, we would have a system. So when we say a system is defined as a set of particles or interacting components. Now in this case, the flask, this can be considered as a system. So a system is defined as a set of particles or interacting components considered to be distinct physical entities for the purpose of study. So this is, we are just studying about, we want to study the work done by the gas on the air outside the balloon. So this can be considered as a single system. So it's a system which is made from a set of interacting particles. And the external condition is called the environment. So the next term that you have to is the meaning of environment. So environment is defined as the combination of conditions and influences outside the system. The gas particles outside the system, the air outside the system can be considered as an environment. So when you say environment, it is a combination of conditions and influences outside the system that affects the behavior of the system. So all the conditions that can affect the system, that can affect the behavior of the system, are called environment. Now in this case I want you to just to draw a formula. I just want to show you how to find the work done by these gas particles. I'm going to drive a formula that can help us to define or to find out the work done on the gas or the work done by the gas. So from our physics background, from our earlier background, we know that work is defined as whenever we are doing work, or whenever the gas is doing work, or we are doing work on the gas. So work is defined as the force that we apply multiplied by the displacement. So work is defined as the product of force and displacement. But I know that here I can just put, like we know that the ratio of two numbers, I can insert like A divided by A is equal to 1. So I can substitute now work. I can write work as force multiplied by area over area multiplied by D, because A over A is 1. So 1 times a number is a number itself. So multiplying this by the same numbers, the ratio of two same numbers, will not affect the equation. So it will remain the same. Now this is equal to, now I can rewrite this as force divided by area multiplied by A times D. Now from the definition of pressure and volume, pressure is defined as the ratio of force over area, force per unit in a given, the amount of force exerted in a given area is called pressure. So this is P, this is equal to pressure, and area times distance is called, the area multiplied by distance is the change in volume. Change in volume, because volume is defined as change in volume is equal to area multiplied by the distance traveled. So this is the same as the change in volume. So now the total work done is now defined as pressure multiplied by the volume change, or change in volume. So the work done by, or the work done on the gas, or the work done by the gas is defined as, or is given by the total amount of pressure multiplied by the volume change. Here pressure can be considered as constant, so it's only that the volume that changes. So work done is defined as the work done by the gas, or the total work done on the gas is defined as, or given by, the product of pressure and volume change. And you know that the work done, the unit of work done is, the assignment of work is joule. So that's how we find work done.